So, performance mapping is all about precision farming and yield maps and how we use yield maps. So, yield mapping, what's it all about? Is it something brand new? Well, no. Here's a picture of somebody cutting a cornfield in the Midwest a long, long time ago, and you can see that they're weighing the bags of seed. They basically want to identify the part of the field which is the highest yielding so they can reuse that seed to plant their crops the following year. So the idea of yield mapping and it being useful to know how things vary across the field, you know, really we've always known. And here's one of the earliest yield maps that I can find, which is from the 1930s, where again they're looking at where yield varies across the field and trying to understand actually how it varies and how that can help them to make management decisions. Mapping got a bit easier when we can sort of put our pencils and rulers away, when sort of GIS, Geographical Information Systems, made making fancy pretty maps a lot easier in the 80s. And then ultimately in the UK, that was all put together with GPS, really by Massey Ferguson in the early 90s, when we got the first practical yield mapping system in the UK. So just looking at it purely from a GPS precision farming yield mapping perspective, we've been at it for over 20 years. And as far as looking at yield variation, we've always known that's a good idea. But the problem has been that all this data which we're collecting, and today, you know, yield mapping systems either come with the combine or can be easily retrofitted. The problem is that it's a bit of precision farming data which isn't like a lot of the other precision farming data that we collect. So, for example, up the top there, we can see a nutrient map basically will give you a phosphate application map. So a phosphate nutrient map, very straightforward to turn that into a phosphate application map. A satellite image on the left-hand side there at the bottom, okay, that's a reflection of crop nitrogen uptake, so that can be converted quite easily into a nitrogen map. So some precision farming data gives you answers, but the thing is with yield maps is that they're retrospective, okay? They're not looking forward, they're looking back at what happened, so they tend to raise more questions than they do give answers. And in some cases, they will raise a heck of a lot of questions, okay? Here's my yield map, here's how it varies. Well, I think that might be because of this, that might be because of compaction, or not really quite sure what that is. And maybe that was because it was a funny year. So the problem is they tend to, or the thing that we have to deal with is that they can raise lots and lots of questions, and they may be different questions. So how do we deal with this when we're trying to interpret maps is the sort of perennial thing that that farm managers will have to sort of think about. And it can lead people to be a bit sceptical about them. So sceptical, in fact, that some people actually go and produce websites to talk about what they think about them. But I don't agree with that website, because I think that, and neither does that farmer actually, that's just a bit of a tagline to get you in. It succeeded with me because I went and had a look at it. I think there's a way of interpreting this data and making use of it and getting to a management decision, because that's what we really want to do. We want to be able to affect our management decisions, because that's the only way we're going to get some benefit on farm from using our yield data. We want them to get them away from the pretty maps, the pretty wallpaper, and actually get the data, use the value that's in there to actually make some management decision. And performance mapping is something which I think can do this. Okay, so what we want to do with performance mapping is we want to look at the yield maps we've got, and we really want to rationalise all these multiple bits of data, these multiple harvests we get, into one single map or one single sort of decision system, if you like. And the problem's always been in the past when people have started yield mapping, but initially people said, well, you've got to collect some data. So you don't want, if you haven't got enough data, you can't really make any decisions, because, you know, last year wasn't a typical year. Okay, let's look at 2012. It was too wet. 2011, that was too dry. That wasn't a typical year either. So you need to build up a supposed database. So you've either got not enough data, and then all of a sudden it seems that you cross over a very fine line, and all of a sudden you've got too much data. So you're looking at this great big vast amounts of information and thinking, what can I do with it? And very often this is what you end up feeling like, a bit overwhelmed by it all. So with performance mapping, we're looking at a way to sort of cut through that. Take all our year's worth of data and make them into one map, which makes some sense. And there's 3 simple steps which we go through, which I won't really elaborate on this, but it's basically collecting the data, making sure it's good data, making sure it's clean, drilling down through common information, and then coming up with areas which we think are appropriate, where we can divide the field up into areas of yield potential. Okay, so first of all, collect your common data. Now, ideally, we would have years of similar crops. Here we've got 5 years of wheat. It could be 5 years of cereals, or indeed, if the controls are strong enough, it can just be your first 3 or 4 years on any particular field. But the more data you've got, the more it allows you to divide up into sort of a common structure. And in this case, we've chosen 5 years of wheat from the 10 or 12 years that we had on this particular farm. And then we'll take each field and we'll start doing some spatial analysis. And to do that, we need to have some sort of common system of identifying where a particular yield is in the field. So we'll put a common grid over a field. Okay, for the sake of clarity, this grid's quite big. In reality, we would divide that field up into much smaller grids, and we can place that common grid over each year's worth of yield map information. So that then allows us to get some sort of comparison from year to year, where we can look at the same bit of a field and start comparing them. So we'll take our 5 years, we'll look at each one of those grids, and we'll look at the yield in each one of those grid squares. Okay? And we'll look at them spatially. So, for example, in the first year, we'll look at a particular square and we'll say, where is that square in relation to the rest of the field? Is it above average yield for the field? Is it below average yield for the field? Or is it about average? And if it's above and below average, how far above and below average is it? Okay? So we can see in the first year, 2002, that was 12 tonnes a hectare. We can then drill down through the same point of the field and do the same for each part, the same part of the field in each year. Okay, so I put the absolute yields down there, but we're not really that interested in the absolute yields. We're more interested in the relative yields. Okay, is it above the average for the field? Is it below the average for the field? Okay, so we can do that for each year, and then we can start to look at things. We can start to look at a temporal analysis. So, in other words, is it always above average in that particular grid? Is it always below average? Or does it change? Sometimes it's above average, sometimes it's below average. So we're looking to see where each part of the field is in terms of the annual situation, and then does that trend carry on from year to year? So we're looking to measure the stability of each little part of the field. Okay, and this particular grid square that I've drilled down through, where we've got 12, 10, 11, 11 and a half and 12 tonnes, okay, that little bit of the field is always above average. It's consistently above average. It's stable, okay? It's always above average. And then I suppose we can say, well, if it's always above average, you know, the likelihood is that it's going to be above average next year. So we go from being a retrospective system, which is what yield mapping is, because it's collecting information, telling you the result of what happened last year, and making it into a predictive bit of a management tool, where we're starting to use the information to predict what's going to happen next year. Okay, so we put the 5 years all into one performance map, and that performance map is now, really it's got 3 zones there. A green zone, which is consistently above average. Okay, these are going to be our high yielding parts of the field. These are going to be our high gross margin or high income parts of the field. We've got areas which are orange, which are red and orange area, which are consistently below average yield. So these are our poor yielding areas, and the red area particularly poor yielding. Okay, so we can be confident that in the following year, if we're planning our management, but we need to manage that part of the field as being a low-yielding part of the field, or do something about it to try and change that. The yellow areas have got no trend, so we're not really sure how they actually are going. We can't be sure how they're going to react next year, because from looking at the past maps, sometimes they might be high, sometimes they might be low. So we've got very distinct areas there, and the next thing we want to do is actually try and use that map in a practical way. So, two ways we can do that. We can either use the maps for doing a field investigation, or we can use them to help with our PK management. And the first thing I'd like to look at is using them to do field investigations, okay? Helping you to understand your fields. Okay, so if we take this map, and we can identify the area there, these are the areas which are going to be consistently low yielding. These are probably the areas that you want to go out and say, what is it that's causing these yield maps to be low, these areas of the field to be low yielding. And when we did this initial study, we found that probably about 50 to 60 of these areas, the farm manager was able to tell me straight away, yeah, I know why they're low yielding. It's because of this, it's because of that soil type, it's because of this problem or whatever. But about 40% of those areas, the farm manager couldn't actually tell me why they were low yielding, or he wasn't actually aware that they were low yielding. So those are the areas that we want to target for field investigation. Go out there, do some sort of soil survey, look at the soil structure, start taking soil samples, tissue analysis, look at the disease which might be in that particular part of the field, try and get a handle on what exactly it is that is causing that area of the field to be low yielding. So some case studies where we've actually gone out and done this. Here's one we just did last week actually. We've got five yield maps that we've looked at, overlaid them, and that makes our performance mapping zones. So the red areas are the consistently low yielding, the green areas consistently high yielding. We've then gone out and done a field investigation, okay, and you can see we've used the map to plan, in this case, where we're going to take some soil samples, some nitrogen samples. So we've got samples in the green area and samples in the red area, okay. So very useful for actually helping you, particularly if you've got a handheld GPS, about where you're actually going to do your field investigations. Okay, this was the good area. Bear in mind that we're not having a brilliant year, but that is actually an area which historically has been high yielding. That's what it looks like this week. It's actually doing quite well. The crop's growing reasonably well there. And if we look at the soil, which is what we did, we can see we've got a good structure there. It's nice and crumbly, it's quite deep, and the stone content's low. Okay, so that's what we got. That's the soil that we've got in our good areas. In our poor areas, we've got a much thinner crop. We've got more stones on the surface there, and when we actually dig down, you can just see the bedrock just appearing at the bottom of that small pit. So we've got a much shallower soil with a much higher stone content there. As far as the analysis was concerned on the nitrogen, which we did for soil mineral nitrogen, we can see that the green area, which is the good areas, got about enough soil mineral nitrogen there to get us at the top end of index 1, index 2. So that's quite a reasonable amount of nitrogen, whereas the low yielding area, we've got very low nitrogens there, actually down below, about 20 kilograms of nitrogen per hectare. Okay, so that's at about an index 0. Okay. So, quite simply here, we've discovered what it is which is driving the low and the high yielding areas within this field. Okay, so the solution with this is if we were going to do an appropriate nitrogen recommendation on this particular field, those two parts of the field would have to get different amounts of nitrogen. Okay. And the other thing we can do with yield maps is we can do a cost-benefit analysis, because if I look at the good yielding parts of the field and the low yielding parts of the field, we can look at the differences in the actual yield there. So I think that there's an actual difference of 1 tonne per hectare. Okay, not a massive one in this thing. But if we put that restricting factor right, our payback is going to be one tonne per hectare, which at 170 pounds a tonne is about 170 pound a hectare. The cost of the extra nitrogen, the difference between the two recommendations, would be about 60 kilos. Okay, so we need about another extra 60 kilos per hectare based on the soil nitrogen supply index of a low yielding field. That's going to have a cost to it, £18 a hectare. The poor yielding area was about 10 hectares, so we've got a cost of potentially addressing that problem with inputs, with a change in inputs, and we've got a benefit potentially if we remove that as a limiting factor. Okay, so this all quite simple calculation allows us to say, well, I've gone out there, it's shown me exactly where the problem is. With my agronomic experience and skills, I've identified what the problem is, so I know what I need to do to put it right, and I can also do a very simple cost-benefit analysis. So just to go through some other examples, again, we've got the poor yielding area here. The poor yielding area, consistent poor yielding area, on a field investigation, the problem was actually to do with soil structure. Okay, we've got a compaction here and a convection pan quite high up here, which is going to be limiting root growth. So again, the suggested management solution was subsoiling. It was a 3 hectare patch. We've got a cost of subsoiling on the left-hand side there, okay, for the area which is affected, and a potential benefit, which is just looking at your low-yielding patch and comparing it with the area directly around it. The only difference we can find was the compaction. Remove that, and then we've got our potential payback for this particular field here. Another low-yielding area consistently, in this case, it was poor drainage. So again, it's to do with the soil physical factors. And the suggestion was to do some mould ploughing or some mould draining. Again, we've got a cost of that on this 6 hectare area which was affected by it. So this is the cost of the mould draining, and a potential benefit, we think, of 3 tonnes per hectare. So again, a cost to removing the problem, and the potential benefit by looking at yield maps and seeing, you know, what's it yielding directly outside of that problem area, and so on. Problem area, again, left-hand side, we've got a difference in the soil type, but this time when we did some tissue analysis, it was coming up with trace element deficiency and manganese. So the solution there was to manganese foliar application, and again, cost on the left-hand side, benefit on the right-hand side. Okay, it's just to help the management decision about, right, well, I found out what the problem is. If I want to put this right, is it going to be worth it? And that's another additional benefit of using the yield maps. As more of a general one, this one, low yielding and high yielding areas, consistently, the high yielding area, very good structure, nice and crumbly, fairly loose. If we actually look, and the farmer was considering minimum tillage or change to minimum tillage on this particular field, that particular part of the field would have been fine. But where we go to the low yielding areas, when we've got a much more compact area, and it's not something which we want to go straight in there and doing some minimum tillage with, unless we do a bit of loosening first, or perhaps do a bit of ploughing in that part of the field. Also, differences in organic matter between those two samples as well. So we've got organic matter as a factor there, so consider applying some organic matter to those parts of the field which were low yielding as well. Okay, so using the performance map for field investigation is one valuable use of a tool. The other area, very quickly, PK management. When we do a variable rate P&K recommendation based on nutrient maps, okay, we look at the variation in the soil supply, the soil analysis, but we need to factor in offtake, what the crop's removing in terms of P&K. And normally we'll just factor that in as a flat rate. So a customer will say, farm manager will say, well, I'm going to be going for 10 tonnes a hectare on that particular part, on that particular field. So that will be the offtake factor. In fact, if we look at our performance mapping there, we can know that the consistently high yield, if it's an average of 10 tonnes a hectare, that's made up of a consistently high yielding part of the field at 12 tonnes and a consistently low part of the field at 8 tonnes. So in each part of the field, we can start to not only look at the variation in the soil supply, but also in the variation of the crop offtake. And in that way, we can actually fine-tune our P&K recommendations, overlaying our yield map with our nutrient mapping information. Okay, so now not only do we at each index have a variable factor for soil, but we remove this flat factor for yield, which are the green bars, and that also starts to vary as well. So again, very simple application for using the information. But we need to be sure that it's a consistent trend and that it's likely to happen again next year. So we need this analysis. Okay, so benefits of field investigation and PK are there to be seen. And what we aim to do is to take out this sort of mystery about how do I look at yield maps, how do I take all this masses of data and make them into something simple, and that's what we aim to do, which we can base a management decision on, and that's what we aim to do with performance mapping.